For this lecture, we can think of a force as a push or pull on an object. Two types of forces we will be dealing with are applied forces and reaction forces. In order to understand stress in materials, we need to understand the relationship between applied and reaction forces. An applied force is a force acting on an object from an external source. In the diagram below, we show a person pushing on an automobile, and that's an example of an external applied force. A reaction force is a force that is created within an object to resist an applied force. A reaction force will resist and match an applied force up to a maximum value, then it can go no higher. In the diagram, we see when the man first starts pushing the car, it resists motion. That's because the car has a reaction force called friction. Newton's first law of force in motion tells us that if a body is at rest, no net force acts on the body. If an external force is exerted on an object at rest and it stays at rest, then there must be an equal reaction force exerted by the object in the opposite direction to the applied force. A woman tries to slide a crate across the floor. A reaction force called friction opposes her applied force. The maximum value of the friction force depends on the weight of the crate and the irregularities between the bottom of the crate and the floor. The friction force will match and oppose the applied force to a maximum value. If the woman increases her push so the applied force is greater than the maximum friction force, the crate will start to slide. Let's say the maximum friction force is 294 newtons. If the woman pushes on the crate with a force of 100 newtons, the opposing friction force will be 100 newtons and the crate doesn't move. If the woman pushes on the crate with a force of 294 newtons, the opposing friction force can match the applied force and will be 294 newtons, so the crate still doesn't move. If the woman pushes on the crate with a force of 350 newtons, the opposing friction force can only generate 294 newtons. Since there is a net force in the direction of the applied force, the crate will slide in this direction. Let's look at a pillar. If a small load is exerted on the pillar, an equal and opposing reaction force is generated in the opposite direction. Therefore, there is no net force on the pillar and the pillar supports the load. If we constantly increase the load on the pillar, the reaction force will reach a maximum value. This is the point where the pillar can no longer support additional load. So if we then increase the load on the pillar, the load will be greater than the reaction force and there will be a net force on the pillar in the direction of the load. In other words, the pillar will fail and start moving towards the ground.